In this video, we're going to look at Cambridge International AS and A-Level Mathematics 9709, Pure Mathematics 1, Paper 1-5, from May-June 2025. Question 1 says the equation of a curve is such that dy over dx is equal to 12 multiplied by the bracket 2x minus 5 squared plus 8x. It is given that the curve passes through the point 2, 4. Find an equation of the curve. To find the curve, we need to integrate, but the equation we've been given includes a bracket, so we need to use the reverse chain rule. So let's make the bracket t. So we can say t is equal to 2x minus 5. Now I can rewrite this equation as 12t squared plus 8x. To use the reverse chain rule, I need to differentiate this equation. So I can say that dt divided by dx is equal to 2. Now I can integrate. I'm going to get 12t with an exponent of 2 plus 1, which is 3, over 3. Now I divide by my derivative. So we can say divided by 2. Then we need to add 8x. X has an exponent of 1, so this becomes squared all over 2. And now I can tidy up. I have 12t cubed over 3 divided by 2, which gives me a denominator of 6, plus 8 over 2, which is 4x squared. Now I need to put my bracket back into t. So this is going to become 12 over 6, which is 2. The bracket of 2x minus 5 cubed plus 4x squared plus c. Now I still need the value for c. The question tells us the curve passes through point 2, 4. I can substitute these coordinates into the x and y values of my equation to find c. So let's make some space. Instead of y, I'm going to say 4 is equal to 2, open a bracket. I have 2x, it's going to become 2 multiplied by 2, minus 5, close the bracket, cubed, plus 4. Instead of x, I'm going to use 2, squared plus c. Now I can put all of this straight into my calculator. We have 2, open a bracket, 2 multiplied by 2, minus 5, close the bracket, cubed, plus 4 multiplied by 2 squared is equal to 14. Now I have 4 is equal to 14 plus c. Subtract 14 from both sides, and I see that negative 10 is equal to c. Now I can write down the equation for the curve. Y is equal to 2, open a bracket, 2x minus 5, close the bracket, cubed, plus 4x squared minus 10. In the expansion of the brackets, the coefficient of x squared is 6 times the coefficient of x. Find the possible values of constant a. Now, this question has given us 2 brackets with exponents, and we have a plus sign between them. We know that when working with algebra with variables, we can only add like terms. The question tells us that the coefficient of x squared is 6 times the coefficient of x. So the first thing we need to do is we need to find the x term and the x squared term from each of our brackets. When looking for a specific term, we can use the formula NCR multiplied by a with an exponent of n minus r, multiplied by b with an exponent of r. Let's find these terms from our first bracket. In this bracket, a is 3, b is ax, and n is the exponent of 5. But we need a value for r. The b term, ax, is the only x term within the bracket. And when we use the formula, we can see that b with an exponent of r will help us with our x term. For this expansion, we need an x term with an exponent of 1 and a square term. So let's start with an exponent of 1. In this expansion, b with an exponent of r will give us x with an exponent of 1. In this case, b is ax, which means ax with an exponent of 1 will give us x with an exponent of 1. That means to find our x term, r is equal to 1. Now we can fill our values into the formula. We have 5c1 multiplied by 3 with an exponent of 5 minus 1, which is 4, multiplied by ax with an exponent of 1. 5c1 is 5, so let's find the value of 3 to the power of 4. 3 to the power of 4. Let's multiply by 5c1, so multiply by 5 is equal to 405. So this term becomes 405 ax. Now let's find the square term, which means that r is equal to 2. So we can say 5c2 multiplied by 3 with an exponent of 5 minus 2, which is 3, multiplied by ax squared is equal to, take your calculator, we have 5c2 multiplied by 3 cubed is equal to 270. That becomes 270 a squared, x squared. These are the two terms we need to consider from the expansion of this bracket. Now let's look at our second bracket. Let's make some space. We're looking at 6 minus x. In this case, a is 6, b is negative x, and n is 4. Again, b is our only x term, which means that the values we are looking for in terms of r will be the exponents of x. So again, we're looking for r values of 1 and 2. Let's start when r is 1. So I can say NCR, which in this case is 4c1, multiplied by 6 with an exponent of 4 minus 1, which is 3, multiplied by negative x with an exponent of 1. Take your calculator. 4c1 gives us 4. Let's multiply by x cubed is equal to 864. Our x is negative, so this becomes negative 864x. Now let's find our square term. We can say 4c2 multiplied by 6 with an exponent of 4 minus 2, which is 2, multiplied by negative x squared. Take your calculator. Let's start with 4c2, multiply this by 6 squared is equal to 216. So now we have 216 x squared. Now let's put these terms back into their brackets. So let's make some space. For the first bracket, we got 405 ax, and put our square term 270 a squared x squared. Now we can add the expansion from our second bracket. We got negative 864x plus 216x squared. The question tells us that the coefficient of the x squared terms is 6 times the coefficient of x. So let's start with the coefficients of the x squared terms. I have 270 a squared, so I can say 270 a squared plus the coefficient of the x term in the second bracket, 216, is equal to 6 times the coefficient of x. So I can say 6. Let's open a bracket. Now let's look at our x terms. I have 405a, so I say 405a minus 864, and this should be the coefficient of x. And now on the right, let's quickly expand the bracket. On the left, I have 270 a squared plus 216 is equal to, take your calculator, 405 multiplied by 6, 2,430, so this becomes 2,430a, 6 multiplied by the bracket of negative 864 is equal to negative 5,184. I have a quadratic equation, so in order to solve for a, let's move all of the terms to the left. I now have 270 a squared. Let's move our a term, so get minus 2,430a. I have 216. Let's add 5,184. And I get 5,400. And this is now equal to 0. In your exam, you do not have a lot of time. So because we're working with such big values, do not try and simplify this equation. You can put this straight into the quadratic formula. So you can say that a is equal to negative b. b is negative 2,430. So we get positive 2,430 plus or minus 2,430 squared minus 4 multiplied by a, 270, multiplied by c, 5,400 under a square root, all over 2 multiplied by 270. Now I can take my calculator and let's find the value of the root. So I can say 2,430 squared minus 4 multiplied by 270 multiplied by 5,400 is equal to, let's square root, and I get 270. So a is equal to 2,430 plus or minus 270 all over 270 multiplied by 2, which is 540. Now let's find a when there's a plus sign in the numerator. Take my calculator and say 2,430 plus 270 divided by 540 is equal to 5. So a could be equal to 5. Now let's find a with a minus sign. Take your calculator, 2,430 minus 270 divided by 540 is equal to 4. So our other value for a is 4. Use completing the square to find the exact solutions of the equation. In completed square form, An equation takes on the format y is equal to a multiplied by the bracket x plus p squared plus q. To find p, you can say p is equal to b over 2a. And to find q, we use the equation c minus ap squared. So let's find p. You can say p is equal to, in our quadratic, b is negative 4, say negative 4, over 2 multiplied by a, which is 4. Now we have negative 4 over 8, which can be simplified to negative 1 over 2. Now with p, we can find q. We can say q is equal to c from the quadratic, negative 1, minus a, which is 4, multiplied by p, negative 1 over 2, squared. Now I can take my calculator and I can say negative 1 minus 4 multiplied by negative 1 over 2, close the bracket, squared is equal to negative 2. So q is equal to negative 2. So in completed square form, my equation becomes y is equal to a, which is 4, put that over here, open a bracket, x minus 1 over 2, close the bracket, squared, minus 2. I need to solve for x. And even though this is in a different form, this is still a quadratic. So we need to make our equation equal to 0. So let's make some space. And I can say 4 multiplied by x minus 1 over 2 squared minus 2 is equal to 0. And now I can find x. Let's move 2 to the right. I get 4 multiplied by x minus 1 over 2 squared is equal to 2. Divide both sides by 4 and I get x minus 1 over 2 in a bracket squared is equal to 2 divided by 4, which is 1 over 2. To get x by itself, I need to square root the bracket. So square root on this side, which means we square root on that side. On the left, the roots and the square will cancel. I have x minus 1 over 2 is equal to, we need to consider the positive and negative root. You can say plus or minus 1 over 2 under a square root. To get x by itself, I need to move this 1 over 2 to the right. So as my final answer, I get x is equal to positive or negative 1 over 2 under a square root plus 1 over 2. Part B says, hence solve the equation 4 tan theta is equal to 4 plus 1 over tan theta. The word hence tells us that we can use our answer from part A to help us with this question. Part A used a variable of x. So in this case, let's turn tan theta into x. So the equation becomes 4x is equal to 4 plus 1 over x. In order to solve for x, I need to multiply all of my terms by x. And I get 4x squared is equal to 4x plus 1. We have a quadratic, so let's move our terms to the left. 4x squared minus 4x minus 1 is equal to 0. This is the equation we were given in part A, and we found that x is equal to positive or negative the root of 1 over 2 plus 1 over 2. Now we can substitute tan theta back into x. Say tan theta is equal to positive or negative 1 over 2 under a square root plus 1 over 2. And we can use this to find the values of theta. All we need to do is substitute this value into the inverse of tan. So let's find theta when we have a positive root. Take your calculator. You can say inverse tan is equal to the square root of 1 over 2 plus 1 over 2 is equal to 50,36. So we can say theta is equal to 50,36 degrees. Now let's find theta with a negative root. So I can say shift tan, negative root of 1 over 2 plus 1 over 2 is equal to negative 11,7. So theta is equal to negative 11,70 degrees. The question asks us to find theta in the domain between 0 and 180 degrees. And the easiest way to do this is to draw a diagram. So let's make some space. And I'm going to draw in my x and y axes. We are working with tan theta. So let's sketch a very simple tan graph. My asymptote lies at 90. Now I can sketch in my tails. We have to consider an angle of theta at negative 11 degrees. So let's sketch this part of our graph as well. We know that theta is equal to 50,36 degrees. So let's put this one in over here. All values of theta that we need to consider have the same y coordinate. So let's draw in a horizontal line. This line does not touch our graph anywhere else, which means this is the only value of theta that we need to consider here. The other value we got was negative 11,7 degrees, and that will sit down here. But this angle sits outside of our domain. We cannot use it. But we need to look for any values of theta that we potentially can use. So let's draw a horizontal line. And we see that this line touches our point over here. We need to consider this point, this value of theta. Remember that if points have the same y coordinate, they sit equidistant from our x-intercepts. Our original point is negative 11,7 degrees. It sits 11,7 degrees to the left of 0, which means that our second point sits 11,7 degrees to the left of 180. So I can take my calculator and I can say 180 minus 11,7 is equal to 168,3. This is a value of theta that I need to consider. So I can say theta is equal to 168,3 degrees, or the value we originally found, 50,36 degrees. These are the two angles that sit within the given domain. The diagram shows part of the curve. The shaded region is bounded by the curve, the line x equals 2, and the x-axis. Find the volume formed when the shaded region is rotated 360 degrees about the x-axis, giving your answer correct to 2 decimal places. Now, before we do anything, we need to determine the x restrictions. And from the diagram, we can see that x is equal to 2. But we need the restriction on this side. And we can see that the x-coordinate is the x-intercept of this curve. To find the x-intercept, we make y equal to 0. So our equation will become x squared minus 1 over x squared is equal to 0. To solve for x, let's move our fraction to the right. We get x squared is equal to 1 over x squared. Let's multiply both sides by x squared. We get x to the power of 4 is equal to 1. Now we can root 4 on both sides, and we see that x could be equal to positive or negative 1. But this curve intercepts the x-axis to the right of the y-axis, where x is positive, which means this value is 1. Now that we have our restrictions, let's make some space, and we can consider our equation. To find a volume of revolution, the first thing we need to do is square our equation. So I can say that y squared is equal to x squared minus 1 over x squared squared. In this case, let's expand our bracket. I'm going to get x with an exponent of 4, x squared multiplied by negative 1 over x squared. The x will cancel. I get negative 1, double it, get negative 2, plus 1 over x to the power of 4. This is the equation that I need to integrate. So let's rewrite this as y squared is equal to x with an exponent of 4 minus 2 plus x with an exponent of negative 4. And now I can integrate. I'm going to get x with an exponent of 4 plus 1, which is 5, over 5. My constant becomes my x term, so negative 2x. Then I have x with an exponent of negative 4 plus 1. This becomes x with an exponent of negative 3 over negative 3. So we can say minus, and then over 3. Now I need to substitute my x restrictions into this equation. Let's start when x is 1. I'm going to make some space. We're going to have 1 with an exponent of 5 over 5 minus 2 multiplied by 1 minus 1 with an exponent of negative 3 all over 3. Remember that regardless of whether an exponent is positive or negative, if you have a base of 1, your value will remain as 1. So now we can take our calculator, and we're going to have 1 over 5 minus 2 multiplied by 1, which is simply 2, minus 1 over 3 is equal to negative 32 over 15. You can say negative 32 over 15. Now let's substitute 2 into our x values. We're going to get 2 exponent of 5 over 5 minus 2 multiplied by 2 minus 2 with an exponent of negative 3 over 3. And you can put this straight into your calculator. We have 2 with an exponent of 5 over 5 minus 2 multiplied by 2 minus the fraction of 2 with an exponent of negative 3 over 3 is equal to 283 over 120. 283 over 120. Now we subtract the smaller value from the greater one. We have negative 32 over 15. This value is smaller. So now take your calculator. We already have 283 over 120. We're going to subtract a negative, which means we can add 32 over 15 is equal to 539 over 120. So we can say 539 over 120 To finish our answer for the volume, we multiply this by pi. Question 5 tells us that a diagram shows a sector ABD of a circle with center A and radius 10 centimeters. The perpendicular bisector of AB passes through D. Part A says find the perimeter of the shaded region BCD, giving your answer correct to 1 decimal place. Now, to find the perimeter of BC and D, we already have BC of 5 centimeters, so we need CD and we need DB. Angle ACD is a 90-degree angle, and we also know that AD is 10 centimeters because this is the radius. We're going to use this to find the length of CD, and we can use Pythagoras. So we can say that CD is equal to the length of the hypotenuse, 10 squared, minus AC, 5 squared, all under a square root. Now you can take your calculator, the square root of 10 squared minus 5 squared is equal to 5 root 3. You can say 5 root 3. That's the length of CD. But I need the length of arc BD. And to find an arc length, I need the angle at A. So I need to use trigonometry to find it. The sine rule tells me that sine A over the opposite side of the triangle, which in this case is CD, is going to be equal to another given angle. I know that C is 90, so I can say sine C over the opposite side of the triangle, AD. And I can use this to find the value of A. So we can say that sine A is going to be equal to, let's multiply both sides by CD, CD multiplied by sine C, all over AD. And now I can fill in my values. We have sine A, CD is 5 root 3, I can say 5 root 3. C is 90 degrees, so sine 90 is 1. So 5 root 3 is our numerator. It's over AD, which is 10. Sine A is equal to 5 root 3 over 10, but I want the value of A, so I need to use the inverse of sine. So I can say inverse sine, fraction of 5 root 3 over 10 is equal to 1 over 3 pi. This is my angle A, which is equal to 1 over 3 pi. Now I can use circular measure to find the value of BC. And we know that the arc length of BC is going to be equal to r theta. R is 10, so this becomes 10 multiplied by 1 over 3 pi. And for now, we're going to leave this as it is. Now we can find the perimeter BCD. BC is 5 centimeters, I can say 5, plus CD, 5 root 3, plus my arc BD, 10 over 3, pi. Put this into your calculator. 5 plus 5 root 3 plus 10 over 3 pi is equal to 24,1322. The question asks us to round off to 1 decimal place, so we get a perimeter of 24,1 centimeters. Part B says find the area of the shaded region BCD. giving your answer correct to 1 decimal place. And we can see that the shaded area is the area of the entire sector less the area of the triangle. So let's make some space and find the area of the sector. For a sector, we use the formula 1 over 2 r squared theta. So in this case, we have 1 over 2. We know that r is 10 squared. And we found angle A, our value for theta, is 1 over 3 pi. So now you can take your calculator and you can say 1 over 2 multiplied by 10 squared, which is 100, multiplied by 1 over 3 pi is equal to 50 over 3 pi. I'm going to leave my answer like this for now, 50 over 3 pi. Now we need the area for the triangle. And we can see that C is a 90-degree angle. So for the triangle, we can use the formula 1 over 2 multiplied by base multiplied by perpendicular height. So we have 1 over 2. Our base is 5, so say multiplied by 5. And in part A, we found the perpendicular height, CD, to be 5 root 3. Now I can take my calculator, say 1 over 2, multiplied by 5, multiplied by 5 root 3 is equal to 25 root 3 over 2. Let's leave that as it is for now. Root 3 over 2. To find the shaded area, I can take the area of the sector and subtract the area of the triangle. So I can take my calculator and I can say 50 over 3 pi minus, create a fraction, 25 root 3 over 2 is equal to 30,709. The question wants our answer to 1 decimal place. So we get 30,7 centimeters. Each year on her birthday, Ananya receives some money from each of her parents. On Ananya's first birthday, her father gives her $10. Every subsequent year, her father gives her $5 more than he gave her the previous year. On Ananya's first birthday, her mother also gives her $10. Every subsequent year, her mother gives her 20% more than she gave her the previous year. Part A says, show that on Ananya's 11th birthday, she receives more from her mother than from her father. In order to answer this question, we need to determine how much money each of Ananya's parents gave her. So let's start with her father. The question tells us that on her first birthday, he gave her $10. Every subsequent year, her father gives her $5 more. The amount her father gives her increases by $5. So this is an arithmetic progression with a constant difference of 5. So for her father, we know that our first term, the initial amount of money he gave her is 10, and the constant difference, D, is 5. We want to know how much money the father gave Ananya on her 11th birthday. So to calculate, N will be 11. So now we can say for an arithmetic progression, Tn is equal to A plus the bracket of n minus 1 multiplied by D. A is 10 plus n is 11. 11 minus 1 gives us 10 multiplied by D, which is 5. 5 times 10 is 50 plus 10 equals 60. This is the amount of money that Ananya's father gives her on her 11th birthday. So let's see how much money her mother gives her. Let's make some space. On her first birthday, her mother also gives her $10. Every subsequent year, her mother gives her 20% more. So we are working with a geometric progression. So in this case, A is also 10. The amount of money increases by 20%, which means our R value is 1,2. So our ratio R is equal to 1,2. We want to know how much money Ananya got on her 11th birthday. So again, N is equal to 11. For a geometric progression, we say Tn is equal to A multiplied by R with an exponent of N minus 1. In this case, A is 10 multiplied by R, 1,2. N is 11, so N minus 1 is equal to 10. Now you can take your calculator, 1,2 with an exponent of 10 multiplied by 10 is equal to 61,917. We're working with money, so we always round off to 2 decimal places. And we get 61,992. This amount is greater than the amount of money Ananya got from her father. So we have now shown that she receives more from her mother. Part B says find the total amount of money Ananya receives up to and including her 18th birthday. To find the total amount of money, we need to determine the amount of money her mother gave her and the amount of money her father gave her. So we need to look at the sum of an arithmetic progression and the sum of a geometric progression. So let's start with Ananya's father. And we're working with an arithmetic progression. To find the sum of terms, we say Sn is equal to n over 2, open a bracket, 2a plus n minus 1 multiplied by d. A is our initial amount. Her father gave her $10, so A is 10. The difference, D, is 5. And we are calculating the amount up to and including her 18th birthday. So N is 18. Now we can fill in our values. We can say the sum of 18 years is equal to 18 over 2, which is 9. Open a bracket. 2 multiplied by A, which is 10, plus N is 18, N minus 1 is 17, multiplied by D, which is 5. And you can put this straight into your calculator. So let's say 2 multiplied by 10 plus 17 multiplied by 5 multiplied by 9 is equal to $945. Now let's see how much money Ananya receives from her mother. Her mother's payments take on a geometric progression. So to find the sum, we're going to use Sn is equal to A multiplied by 1 minus R exponent of n over 1 minus R. The initial amount, our A value, is 10. So A is 10. We know that R is 1,2 and 18 years, so N is 18. So now we can say the sum of 18 years is equal to 10, open a bracket, 1 minus R, 1,2 with an exponent of 18, all over 1 minus 1,2. And you can put the whole fraction into your calculator. Let's create a fraction. We have 10, open a bracket, 1 minus 1,2 with an exponent of 18, close the bracket, over 1 minus 1,2 is equal to 1,281 comma 1,666, round off to 2 decimal places, and we get 1,281 and 17 cents. This is the amount Ananya's mother gave her. So to find the total, we're going to add the amount from her father, 945. Take your calculator. Let's say plus 945 is equal to 2,226 and 17 cents. 2,226 and 17 cents. This is our final answer. In the parallelogram ABCD, the coordinates of A are 3, 7, the coordinates of B are 6p, and the coordinates of D are 1p. It is given that the gradient of AB is negative 2 over 3. Part A says find the value of P. We are given the coordinates of A, the coordinates of B, and the gradients, and we can use this to find the value for P. To find the gradient, we use the formula m is equal to y2 minus y1 over x2 minus x1. Let's say that A is 0.1 and B is 0.2. So now we can say P minus 7 over 6 minus 3 is equal to the gradient, negative 2 over 3. P minus 7 remains as our numerator, over 3 is equal to negative 2 over 3. Let's multiply out our denominators. We get P minus 7 is equal to negative 2, which means that P is equal to 5. Part B asks us to find the coordinates of point C. So let's start by making a sketch of the points that we know. Point A has coordinates of 3, 7. B has coordinates of 6p. And in part A, we found that P is 5. So let's put this over here. And now we know that point D is 1p. The question tells us that we are working with a parallelogram ABCD. When we name a parallelogram, we do not necessarily name the letters in alphabetical order. We actually name them in a clockwise direction. This means that point C needs to lie somewhere here. We're working with a parallelogram, ABCD, and one of its characteristics is that the diagonals bisect. This means that AC has the same midpoint as line DB. So if we can find the midpoint of DB, we can use this to find the value of C. To find a midpoint, we use the formula midpoint is equal to x1 plus x2 over 2 for the x coordinate and y1 plus y2 over 2 for the y coordinate. So let's find the midpoint of DB. I'm going to say mid DB is equal to 1 plus 6 over 2 and 5 plus 5 over 2. 1 plus 6 gives us 7, so we get an x-coordinate of 7 over 2. 5 plus 5 is 10, divided by 2 gives us 5. This midpoint is also the midpoint of AC, and now we can use this to find the value of C. So let's give C coordinates x, y. We know that the x-coordinate of A, which is 3, plus the x-coordinate of C, let's call it x, divided by 2, gives us the x-coordinate of the midpoint, 7 over 2. This means that 3 plus x is equal to 7, which means the x-coordinate of C must be 7 minus 3, so x is equal to 4. Now let's find the y-coordinate. The y-coordinate of A is 7, plus the y-coordinate of C, let's call it y, over 2, is equal to the y-coordinate of the midpoint, 5. Multiply both sides by 2, and we get 7 plus y is equal to 10. Now we can subtract 7, and we see that y is equal to 3. Now we have an x-coordinate of 4 and a y-coordinate of 3. So the coordinates of point C are 4, 3. Part C says find the area of the triangle formed by the perpendicular bisector of AB and the x and y axes. So let's put our parallelogram onto our page. Let's draw in some y-axes and some x-axes. The triangle is formed by the perpendicular bisector of AB and the axes. This means that the perpendicular bisector of AB will cross both of our axes, and this forms a triangle. Let's make this red. To find the area of this triangle, we can use 1/2 multiplied by base multiplied by perpendicular height, because the axes are perpendicular, so we have a 90-degree angle triangle. We need to find the x and y intercepts. So to do this, we need an equation for this bisector. It is the perpendicular bisector, which means it runs to the midpoint of AB. So let's find the coordinates of this point. You can say the midpoint is equal to 3 plus 6 over 2, and y coordinates of 7 plus 5 over 2. 3 plus 6 gives us 9, so the midpoint has an x-coordinate of 9 over 2, and a y-coordinate, 7 plus 5 is 12, divided by 2 gives us 6. This is the midpoint. These are the coordinates we're going to use to find the equation of the line. But we also need a gradient. This line is perpendicular to AB, and the question has told us that the gradient of AB is negative 2 over 3. So to find the gradient of the perpendicular, we flip the fraction upside down and change the sign. And we now have positive 3 over 2. Now we can put these values into the equation for a straight line. Our y value is 6, so I can say 6 is equal to m 3 over 2 multiplied by x 9 over 2 plus c. Let's expand these brackets. We get 6 is equal to 27 over 4 plus c. To find c, all we have to do is move our fraction to the left. 6 minus 27 over 4. Take a calculator. 6 minus 27 over 4 is equal to negative 3 over 4. Negative 3 over 4. This is our c value, but it is also our y-intercept. We can make a note of this on our diagram. Now that we have our equation, we can find the x-intercept. Our equation now is y is equal to 3 over 2 x minus 3 over 4. To find the x-intercept, y is equal to 0. So let's move negative 3 over 4 to the left. I get positive 3 over 4 is equal to 3 over 2 x. To get x by itself, I need to divide both sides by 3 over 2. So I can take my calculator. I say 3 over 4 divided by 3 over 2 is equal to 1 over 2. This is my x-intercept. I can write this on my diagram as well. To find the area of a right angle triangle, we use base multiplied by perpendicular height. In this case, our base can be the distance along the x-axis, 1 over 2. We are working with distance, and the y-intercept may be negative 3 over 4, but it is 3 over 4 units away from the origin. So we can use this as our perpendicular height. So for the area of the triangle, I can say 1 over 2 multiplied by base, 1 over 2, multiplied by height, 3 over 4. Now I can take my calculator, say 1 over 2, multiplied by 1 over 2, multiplied by 3 over 4 is equal to 3 over 16. This is the area of the triangle. The equation of a curve is y is equal to x cubed plus ax squared plus bx plus 5. The curve has a stationary point at 1, 9. Part A says find the values of the constants a and b. In this question, we are looking for the values of two unknowns, which means we need to use simultaneous equations. So we need to create two equations. The question tells us that the stationary point has coordinates 1, 9. That means that when x is 1, y is 9. So to create our first equation, we can say y, which is 9, is equal to x is 1, 1 cubed is still 1, plus 1 squared multiplied by a, which is a, plus b multiplied by 1, which is b, plus 5. Let's tidy this up. 1 plus 5 is 6. 9 minus 6 gives us 3. So 3 is equal to a plus b. Let's leave this as it is for now. The point is a stationary point, and this means that at this point the gradient of the curve is 0. So let's find the equation for the derivative, dy over dx. dy over dx is equal to 3x squared plus 2ax plus b, and our constant falls away. This is our stationary point. So when x is 1, this equation is equal to 0. So now we can see that 0 is equal to 3 multiplied by 1 squared, which is 3, plus 2a multiplied by 1, which is still 2a, plus b. In both equations, b does not have a coefficient. So on the left, let's make it the subject. And I can say 3 minus a is equal to b. Now I can substitute 3 minus a into this value over here. And I have 0 is equal to 3 plus 2a plus 3 minus a. 0 is equal to 3 plus 3, which is 6. 2a minus a gives me positive a. Move 6 to the left, and I can see that negative 6 is equal to a. Now that I have a, let's find b. So I can say 3 minus negative 6 is equal to b, which means that 9 is equal to b. Part B says find the coordinates of the other stationary point. Let's start with the equation of the derivative. dy over dx is equal to 3x squared plus 2ax plus b. In part A, we have just found that a is negative 6 and b is equal to 9. So now this equation becomes 3x squared. 2 multiplied by negative 6 is negative 12, so this becomes minus 12x plus b, which is 9. We are looking for the coordinates of a stationary point, so we can make our equation equal to 0. To find x, let's use the quadratic formula. You can say x is equal to negative b. B is negative 12, so this becomes positive 12, plus or minus b squared, negative 12 squared, minus 4, multiplied by a, which is 3, multiplied by c, which is 9, all under square root, all over 2 multiplied by 3, which is 6. Now you can use your calculator to find the value of the root. So I can say negative 12 squared minus 4 multiplied by 3 multiplied by 9 is equal to 36. Let's square root and we get 6. So x is equal to 12 plus or minus 6 all over 6. Now to find x, I can take my calculator and I can say 12 plus 6 divided by 6 is equal to 3. This is the x coordinate of the other stationary point, but I still need the y coordinate. To find y, I can substitute 3 into my x values in this equation over here. So I can say y is equal to x cubed becomes 3 cubed. A is negative 6, so this becomes negative 6 multiplied by 3 squared. B is 9, so this becomes plus 9 multiplied by 3 plus 5. Now I can put all of this into my calculator. So I can say 3 cubed minus 6 multiplied by 3 squared plus 9 multiplied by 3 plus 5 is equal to 5. So y is equal to 5. That means that the coordinates of the other stationary point are 3, 5. A point P is moving along part of the curve in such a way that the y-coordinate of P is increasing at a constant rate of 6 units per second. Find the rate in which the x-coordinate of P is increasing when x is 5. Here we are working with rate of change, so we need to use the chain rule. dy over dx is equal to dy over dt multiplied by dt over dx. The question tells us that the y-coordinate is increasing at a constant rate of 6 units. So dy over dt is equal to 6. It asks us to find the rate in which the x-coordinate is increasing. So we need to find dx over dt. This is our unknown value. To find dx over dt, we need a value for dy over dx. And we already know that the equation dy over dx, which we found in part B, is 3x squared minus 12x plus 9. The question asks us to find the rate of x when x is 5. So we substitute 5 into these x values. So we have 3 multiplied by 5 squared minus 12 multiplied by 5 plus 9. And you can put this straight into your calculator. We have 3 multiplied by 5 squared minus 12 multiplied by 5 plus 9 is equal to 24. This is our value for dy over dx. So now the equation for the chain rule becomes 24 is equal to dy over dt, which is 6, multiplied by dt over dx. Let's quickly divide both sides by 6. and we see that 4 is equal to dt over dx. But the question is not asking us for dt over dx. It is asking us for dx over dt, the reciprocal fraction. And we know that 4 can be written as 4 over 1. To find the reciprocal fraction, we simply turn our fractions upside down. That means that dx over dt is equal to 1 over 4. Question 9 says the functions f and g are defined as follows. Part A says describe fully the transformations that have been combined to transform the graph of y is equal to f of x to the graph of y is equal to g of x. We always start with a possible stretch. First, the stretch parallel to the x-axis. But when we compare the graphs, we have an x in both equations. There is no horizontal stretch. So now we can look at a vertical stretch. F of x takes on equation cos x, but g of x takes on equation 3 cos x. F of x has been stretched by a scale factor of 3. So it's our first point in our answer. We can say there is a stretch of a scale factor of 3 parallel to the y-axis. Now we need to look for a translation. G of x includes the bracket x minus pi. That means every coordinate in f of x has now shifted pi units to the right. G of x also includes a constant of positive 2, which means there's been a shift upwards of 2 units. So for the second point in our answer, we can say that there is a translation of pi 2. Part B says on the given axes, sketch the graphs of y is equal to f of x and y is equal to g of x. Now we've been given axes, but we have no values along our y-axis. The best place to start is to make some notes of the coordinates that we're going to use, as this gives us a general idea of where our sketches will lie. Let's start with y is equal to f of x, which takes on the equation of a basic cosine graph, cos x. We know that the graph for cos x has a maximum point at its y-intercept at 0, 1. The x-intercept sits at 90 degrees, 0. In this case, we are working with radians, so our x-intercept is 1 over 2 pi, 0. It also has a minimum turning point at 180 degrees, negative 1. Let's change this to radians, and our minimum point becomes pi, negative 1. Now that we have these coordinates, we can manipulate them for the coordinates for the graph of g of x. So let's write down the equation of 3 cos x minus pi plus 2. The maximum point for cos x takes on coordinates 0, 1. But for g of x, our point has shifted pi units to the right. So our x-coordinate will be pi. The y-coordinate for cos x is 1. G of x has been stretched by a scale factor of 3. 1 multiplied by 3 is 3. Then it shifted 2 units upwards. 3 plus 2 gives us 5. For the original x-intercept, we've shifted pi units to the right. So the x-coordinate becomes 3 over 2 pi. For the y-coordinate, 0 multiplied by 3 is still 0, plus 2 gives us 2. For the minimum point, pi plus pi gives us an x-coordinate of 2 pi. Negative 1 multiplied by 3 is negative 3, plus 2 gives us negative 1. Now we have 6 coordinates that we can consider. Cos x has an x-intercept of 1 over 2 pi. So let's include this along our x-axis. And 3 over 2 pi as well. Now we can look at y coordinates. We have a point of 1, a point with 2, and a point with 5. Let's put this up here. The minimum turning point and both minimum turning points for both graphs have y coordinates of -1. So we need to consider -1 as well. The most important thing to keep in mind here is that both f of x and g of x have limited domains. F of x considers x values between 0 and pi. So now we can plot these 3 points. We have a point on the axes at 0, 1, on the x-axis at 1 over 2, 0, and a point at pi -1. And now we can join these points together. These are the only points that we can consider in this domain. When you're in your exam, you need to ensure that your marker knows which graph pertains to which equation. So let's label this graph as f of x. Now let's look at our points for g of x. We have pi 5, that will sit over here, 3 over 2 pi 2, that will sit there, and 2 pi -1. These points fall into the given domain of x values between pi and 2 pi. So these are our graphs. Let's label our second graph g of x, and this is our final answer. Part C asks us to find the equation g to the -1 f of 1 over 3 pi. Let's start by substituting 1 over 3 pi into f of x. So I'm going to say f of 1 over 3 pi is equal to cos, open a bracket, 1 over 3 pi. And you can put this straight into your calculator. So we can say cos 1 over 3 pi is equal to 1 over 2. Let's make a note of this over here. Now we're working with the equation g to the -1, 1 over 2. Now, when we see equations with g to the -1, f to the -1, it normally tells us that we are working with inverse functions. But remember that in this question, we are working with trigonometric ratios. And as an example, we know that, let's say we use sine 90 degrees, because we know that sine 90 degrees is equal to 1. But we can also write this as the inverse. Sine to the -1, 1 is equal to 90 degrees. This means that in this case, the equation for g of x is equal to 1 over 2. And we need to find the value of x. So let's write our equation for g of x. 3 cos, open a bracket, x minus pi, plus 2. We're going to make this equal to 1 over 2. And now we need to solve for x. So let's move the constant 2 to the right. On the left, we have 3 cos, the bracket of x minus pi, is equal to 1 over 2 minus 2, which gives us -3 over 2. To get the ratio by itself, let's divide both sides by 3. And we're going to have cos x minus pi is equal to -3 over 2 divided by 3, which gives us -3 over 6. Simplify, and we get -1 over 2. Now, to find x, we need to use the inverse function. So I'm going to say cos to the -1 negative 1 over 2 is equal to x minus pi. Now you can take your calculator. You say shift cos with a bracket of negative 1 over 2 is equal to 2 over 3 pi, 2 over 3 pi, and this is equal to x minus pi. To get x by itself, let's add pi to both sides. 2 over 3 pi plus pi gives us 5 over 3 pi, and this is equal to x. Part D asks us to explain why the composite function fg cannot be formed. Now, a composite function cannot be formed when the domain of the output function does not include the entire range of the input function. So, as our answer, we can say the domain of f does not include the whole range of g, and this is our final answer. Question 10 tells us that the equation of a circle is x squared plus y squared plus 4x minus 8y minus 12 is equal to 0. Part A says find an equation of the tangent to the circle at point 28, giving your answer in the form ax plus by plus c is equal to 0. A tangent is a straight line, so to find the equation, we need the coordinates of one point and the gradient. We've been given the point 28, but we need the gradient of the tangent. Remember that a tangent is perpendicular to the radius at that point. So if we can find the gradient of the radius, we can find the gradient of the tangent. To find the gradient of the radius, we need the coordinates of the center of the circle, and we can use this equation to find them. So we can say the center C. For the x coordinate, we look at the coefficient of x, which is 4, divided by 2 gives us 2. Change the sign, and we get negative 2. For the y coordinate, look at the coefficient of our y term, negative 8. Divided by 2, we get negative 4. Change the sign, and you get positive 4. This is the center of the circle. And we also have point 2, 8. Now we can use this to find the gradient of the radius. So we can say the gradient of the radius. Let's say that's the center is our first point and 2, 8 is our second. So we can say 8 minus 4 over 2 minus negative 2, which gives us 4 over 4, which is equal to 1. Now that we have the gradient of the radius, we can find the gradient of the tangent. To find the perpendicular gradients, we turn this into its reciprocal fraction and change the sign. 1 can be written as 1 over 1. Let's change the sign, and we get negative 1, which means the gradient of the tangent has to be negative 1. Now we can find the equation of the line. We have a y coordinate of 8, so we can say 8 is equal to m, negative 1, multiplied by x, which is 2, plus c. So we have 8 is equal to negative 2 plus c, which means that c is equal to 10. Now we can write the equation for the tangent as y is equal to m negative 1, so we get negative x, plus c, which is 10. But the question asks us to leave our answer in the form ax plus by plus c. So let's move x and 10 to the left, and we're going to get x plus y minus 10 is equal to 0. Part B says, given that the line x plus 3y is equal to k does not intersect the circle, show that k squared minus 20k minus 220 is greater than 0. When we are working with intersection, we use the discriminant b squared minus 4ac. If two graphs, in this case a line and a circle, do not intersect, the discriminant is smaller than 0. To find our a, b, and c values, we need to make these two equations equal. So let's start with the equation of the circle. X squared plus y squared plus 4x minus 8y minus 12 is equal to 0. And the equation for the line, x plus 3y is equal to k. But if we make these equations equal, we're going to create an equation with x and y variables. So to make it easier, the equation of the straight line has an x term without the coefficient. So let's make it the subject. And I can say x is equal to k minus 3y. To make these equations equal, I can substitute k minus 3y into my x values in the equation for the circle. So this becomes, let's open a bracket, k minus 3y squared plus y squared plus 4 multiplied by the bracket k minus 3y minus 8y minus 12 is equal to 0. Now I need to expand my brackets. So I'm going to get k squared minus 6ky plus 9y squared plus y squared. Expand my next bracket, I get positive 4k minus 12y minus 8y minus 12, which is equal to 0. Now, the question tells us that we need to create an equation in terms of k, which means in the equation we have now, y is our variable. We have a square term, so we have a quadratic. Let's start by adding like terms. 9y squared plus y squared gives me 10y squared. Then I have negative 12y minus 8y gives me negative 20y. I have negative 6ky, so minus 6ky. And now I can look at my constants. Any values do not include y. I have k squared, so I can say plus k squared. I have 4k, so I say plus 4k, and negative 12. And I can make this equal to 0. This equation is going to give me my a, b, and c values. A is the coefficient of the square term. We have 10y squared, so a is equal to 10. B is the coefficient of our y terms. So in this case, b is equal to negative 20 minus 6k. C considers our constants, which in this case is all three of these terms. So I can say C is equal to k squared plus 4k minus 12. Now I can fill these values into the a, b, and c variables for the equation for the discriminant. So let's make some space. I have b squared, let's open a bracket, negative 20 minus 6k, close the bracket, squared, minus 4 multiplied by a, which is 10, multiplied by c, k squared, plus 4k, minus 12. The line and the circle do not intersect, so I need to make this equation smaller than 0. And now we can expand the brackets. Negative 20 squared gives me 400. Negative 20 multiplied by negative 6k gives me positive 120k. So this becomes positive, we need to double it, so 240k plus 36k squared. Now we need to multiply negative 4 by 2 brackets. Negative 4 multiplied by 10 gives me negative 40. So now I have negative 40k squared minus 160k plus 480. And we make this smaller than 0. Once again, I need to add like terms. Let's start with our squares. 36k squared minus 40k squared gives me negative 4k squared. 240 minus 160 gives me 80, get plus 80k. 400 plus 480 gives me 880. And this is all smaller than 0. In our question, our square term is without a constant. So let's divide all 3 terms by 4. I'm going to get negative k squared plus 20k plus 220 is smaller than 0. But in the question, the square term is positive. So let's move everything to the right. And I'm going to have k squared minus 20k minus 220 is now greater than 0. And we have completed this question.